Today I'm going to talk to you about the pH scale and about buffers, and you can find this in section 10.3 and 10.4 in your notes. All right, so the first thing we want to talk about is the pH scale. And the pH scale we looked at a little bit in class already, and we talked about how things with low pH are acidic and things with high pH are basic. And I told you that the scale goes from 0 to 14. But I didn't really talk about why that is. And the reason is because there's a certain amount of H3O plus and OH minus that's always present in water, all right? And that amount is represented by the Kw. So the Kw is equal to the concentration of H3O plus times the concentration of OH minus that's in solution all the time. And that value is always equal to 1 times 10 to the minus 14th. And that negative 14, that is where our scale comes from, because it's a log scale. So every time one of the concentrations changes by a factor of 10, we change 1 pH unit on the scale. All right, so things that are neutral have a pH of 7. Things that are acidic have a pH less than 7, and things that are basic have a pH that's greater than 7. So mathematically speaking, the pH is equal to the negative log of the H3O plus concentration. We are not actually going to do calculations in this class of the pH, but I wanted you to understand that it's on a log scale, which basically means that if we're comparing something that has a pH of 2 versus something that has a pH of 3, then that's tenfold different amount of H3O plus in the solution between the two different samples. So while pH of 1 versus pH of 5 might not seem like that much, it's 4 units, so that's 10 to the 4th difference in the concentration of H3O plus. So that's actually a huge difference. That's a 10,000-fold difference between the pH of 5 versus the one that's the pH of 1. In class, we already talked about the pHs of some common substances. I've listed a bunch of them here, and they're in your notes, and a lot of them should look familiar because we looked at them in class. So, for example, bleach is really high on the pH scale. Battery acid or stomach acid, those are very low on the pH scale. And things like pure water and your blood, those are usually in the neutral range, right in the middle. And as we talked about in class, while detergents and soaps tend to be very basic, things that we use on our own bodies are much closer to neutral. So the hand soap here is listed as 9. The one we did in class was even closer to neutral than that. But like shampoo, for example, is usually in the range of 7 to 10. So milder detergents that we would actually use on our bodies are going to be closer to neutral pH. And you can also see that things that we tend to consume tend to be on the acidic side of the scale, but close-ish to neutral in terms of things that we want to put into our bodies to eat. The next thing I want to talk about are buffers. So a buffer is a solution that resists large changes in pH. And buffers are made up of two components. They have one component that can help neutralize acid if it's added, and they have a different component that can help neutralize a base if it's added. And buffers work in a very specific pH range depending on what the components of the buffer are. Okay, the most common buffer that you or probably one of the most important buffers for you is in your blood. So blood has a very specific range in which it's healthy for you to have your pH. So it should always be between 7.35 and 7.45. So that's a very narrow range. And there's a lot of reasons for this. It has to do with how proteins function, how things can precipitate at different pHs, and things like that. But it's important that your blood stay in that pH range, or you can have all kinds of problems. All right. We can also find buffers in other places. So, for example, our oceans have buffer in them so that the pH stays fairly constant so that sea life can survive. Fertilizers sometimes have buffer in them to help regulate the pH of the soil. You can find them in lots of different places.